Okay. So we're going to continue with what they called practical circuits. I still don't know how they got that name, but so this group is about antenna and transmission line measurements and about dummy loads. We've already gone over the coaxial cable stuff that was mixed in with some other groups, so I left those out of this one. I had to redo this one this morning. And I think some of these may be duplicates that we've already done, but it won't hurt to see them more than once.
Not at all.
So what is an SWR? It's called a standing wave ratio. It's really just a measurement.
Yes. I'm on my way to your house. Come in through the sliding door. Okay. All right, bye.
Bye. It's really just a measurement to show how well your system is matched to the antenna. So we normally have a transceiver that has a 50 ohm input output, and we normally use a 50 ohm coax to connect to an antenna, but unfortunately the antenna is probably not 50 ohms. In the case of a standard half-wave dipole, it's 72 ohms if they're stretched out horizontally. So in order to get a good match, you need a matching device that will convert the 50 ohms to whatever the antenna is so that you can get the maximum power to the antenna. If you had a perfectly matched system, your SWR meter or VNA or antenna analyzer, directional watt meter, whatever you're using, would show you a ratio of 1 to 1. That would be perfect. You'll probably never ever see that, but you might get a 1 to 1.1, 1.2 or something, which would be very, very good. Usually if it's 2 to 1, it works fine. When you get up to 3, most of the transceivers will start reducing power to protect the output transistors. We'll talk a little more about that. So really the SWR is just an indicator of how good a match you have. So the closer it is to 1 to 1, the better.
Gotcha.
So what does an SWR reading of 4 to 1 indicate?
Bravo.
Delta?
Bravo.
Think about it.
Wait a minute, impedance match.
Alpha. Maybe alpha.
We didn't talk about dB.
No, so it has to be really a mismatch. Oh, 4 to 1. Oh my God. I can read. Yeah, sorry. Mismatch.
Yeah, 4 to 1's not good.
Yeah, no, I was seeing in my head. I was seeing, but not with my eyes. 4 to 1. Yeah, that's not good.
On the exam, it's good to read the question twice.
Yes, I should have.
Okay, so like I said, the bigger the mismatch, the higher the SWR is going to be.
Mm-hmm.
And the higher the SWR, the more power you're going to lose in the feed line. And what happens is with a mismatch, you get part of the signal reflected back.
Ah.
Okay, and that can add and subtract to the signal going forward. So you can get a very high standing wave as a result of that combination. And that causes heating in the transmission line. So the more reflected coming back, the more heating you can get. And the heat is just power that's being dissipated, and it's not going to the antenna. So if you're putting out 100 watts and half of it is being reflected back, the most you're going to get to your antenna is 50 watts. And the rest of it is going to be heating up your transmission line. At some point, it could actually cause damage to the transmission line if it was bad enough.
Mm-hmm.
Plus, it could damage your transmitter, unless you got an old tube type. They weren't bothered by the reflections like the transistorized ones.
Right.
So what happens to power lost in a feed line?
Charlie?
Charlie,
Harley. So when you do have a match, okay, you're going to have a very low SWR, hopefully close to 1-to-1, which means that all of your power is going to the antenna and probably going to be radiated depending on the antenna. Now, if it's a compromised antenna with a loading coil, then it's going to have a reduced radiating area, so it won't be quite as efficient. But that's for a different set of things. Like I said, most of the modern transistorized radios will automatically start reducing power when they see an SWR of 3 or higher. I saw that here this last week on my 9700, trying to do some single sideband on 2 meters, and down at the low end was seeing an SWR of 6, and the radio was, instead of 100 watts, was putting out less than 50, and most of it was being reflected back. So why do most solid state transmitters reduce?
Hold on. Hey. Hey. Casper's cut it out.
Delta
Casper, come on.
or Alpha, maybe Alpha, but Delta.
Well, which one? It can only
Delta. But you're not switching, you have right. Oh, well.
Sorry, my dog was going off. I had to put us on mute. Missed that.
Yeah, they do it to protect themselves, to protect the output transistors, because those are usually fairly expensive devices. Typically, $100, $200 for one. And if you have to send it back to the manufacturer to get repaired, it's a lot more than that. Okay, so we talked about what SWR is, but how do we measure it? Okay. There are SWR meters. A lot of radios have a built-in, essentially a directional watt meter, and it will display what the SWR is by calculating the ratio between the forward and reflected power. You can have an external meter that shows SWR. Some of them will also show you forward and reflected. Or you can use a directional watt meter, which really only shows you can measure forward power, and you usually have to switch it to reverse power or reflected power, and then calculate what the ratio is. And like I said before, if you have an SWR close to 1-to-1, you're going to be close to the resonant frequency. It turns out that you can have a low SWR and not really be at the resonant frequency, which I won't go into now why that is, but most antenna analyzers and things that just show you SWR are what most people use to, quote, tune their antenna or to do the match. And it gets you close. But if you actually look at it on a device that displays a Smith chart, you can actually see the resonant points, and they're not necessarily the lowest SWR, but it'll be close. Some of the devices, like nano VNAs and some antenna analyzers, will also measure the capacitive and inductive reactance. And they really have a little built-in signal generator, so you can do a sweep over a wide frequency range to see what the SWR looks like at different frequencies. So when you're using a directional watt meter, like a bird, that's kind of the gold standard. You just measure the forward power, flip the switch, measure the reflected power, and then you have to do some calculations.
Mm-hmm.
There are some SWR meters, analog type, which I'll show you one at the end of this, which is called a twin needle. It actually has two analog meters, and one is showing you forward power and the other is showing you reflected power. And then there's a scale, and where those needles cross, on that scale, it'll tell you what the SWR is. It's a little hard to read. The digital ones that just show you SWR and forward and reflected are a lot easier. So which of the following is used to determine if an antenna is resonant at the desired operating frequency?
Bravo.
Bravo.
Bravo, bravo.
Which instrument can be used to determine SWR of those?
Delta.
Delta.
What reading on an SWR meter indicates a perfect impedance match between the antenna and the feed line?
Charlie.
Yeah, Charlie.
Okay. Another device besides things to measure SWR, and sometimes it's used as a reference, is called a dummy load. And really what it is a non-inductive resistor or group of resistors. Usually it's more than one, all connected together. So it looks like a real 50 ohm non-inductive, non-capacitive resistance. And usually mounted on some form of heat sink so they can dissipate the power. And like a typical one, like I have here, says it's 300 watts, which means it'll handle 300 watts for 10 or 15 seconds before it gets too hot. But it'll handle lower power for longer. You can get them up into the kilowatts. They get quite expensive. Kind of the old standard Heathkit used to make one that was in a gallon bucket filled with oil, and it would handle about 1,000 watts. So what do you use it for? For testing purposes. So you can connect your transmitter to the dummy load and transmit, and you know that you're transmitting into a 50 ohm match, and basically do adjustments and things to make sure that everything is set right, and you're not transmitting on the air.
Right.
people don't necessarily like tuning and transmitting on the air. Putting out.
Okay, we're gonna have problems. We'll stop it.
Say again? Oh,
So what's the primary purpose of a dummy load?
alpha.
What does a dummy load consist of?
Delta.
Delta.
What does a dummy load consist of?
Delta.
No, it's 50 ohm resistor, but that's reactant. So
It's not delta, so we should try again.
Yep. Well, you keyed in on the 50 ohm, so did I, but then I looked at
Bravo.
the resistor. And,
Yeah, it says 50 ohm reactance, and we don't want that.
no, we want resistance.
So bravo.
Bravo.
Finally.
Nope. Bravo.
Bravo, bravo.
Okay. Where's my? I guess I have to stop the share.